Hello guys, welcome back to my channel. So today we're going to do a video on Cisco HSRP, hot standby redundancy protocol. So for this video we have three client-side routers, R1, R2 and R3, and we have the ISP N. So all these three routers are connected to the ISP so that if R1 fails, one of these should be able to pick over. Okay, so if R1 fails, R2 or R3 should pick up, but we don't know who is going to pick up because we're going to configure HSRP so that it basically decides this using virtual IP address. Okay, the HSRP virtual IP address. So on the ISPN we have a loopback interface 8.8.8.8, which is basically going to be used to basically track internet. Okay, just to represent our internet so that the LAN site, if the LAN site can ping 8.8.8.8, it means that there is internet available. So that's what that means. So the ISPN is already configured. Let's double check what's in there. ISPN is already configured, and then R1 is not configured, but R2 and R3 have been configured. So whatever is in R2 or R3 is basically similar to what we're going to see on R1. So we're going to configure R1 completely from scratch, and then we're going to route the traffic going through R1 and see if that works. Then we're going to check what's in R2 and R3, just to compare. So let's just go back. Let's go straight into the into what we have in ISP. We'll go to the ISP. We'll do show IP interface brief. Okay, so the ISP, we see that the serial interfaces have all been configured. Actually, I do have something here. I do have this. Okay, so I'm going to lower this so it's much easier. So on ISP, we see all these interfaces have already been configured. Okay, and we even also have the ISP, the loopback interface also configured. So ISP is good. Router 1, we're going to configure everything from scratch. Okay, so go into configuration mode, put in the IP address, interface serial 1/1, short IP address. IP address is going to be 11.11.11. On the ISP end is going to, on the client end is going to be .2. The ISP end is always going to be .1. 255.255.255.252 is /30. Okay, and this interface serial 11, we're going to call it an outside interface. So let's call it IP not outside. Okay, so it's going to be an outside interface because it's the internet facing interface. So we'll do the same thing on the LAN side, which is the inside interface. Interface /0 /0. More short. IP address 172.16.20.1. .0. Okay, we call this one IP not inside. Okay, it's an inside interface. So so right now, if R1 can already ping the ISP LAN, that's the directly connected interface. Okay, let's say if you try a ping to 11.11.11.1, which is the ISPN, ping should work. But if we try to ping instead the loopback, yeah, that should not work because the R1 doesn't know how to get there. Okay, so for that we're going to configure a static route on R1 so that it can be able to reach a loopback, which represents any IP on the internet. Okay, so let's go configure So basically, if R1 wants to reach, if R1 or any IP address or any device wants to get to any IP on the internet with any subnet mask, the gateway through R1 is going to be 11.11.11.1. Okay, that's what that means. So which means if we do a ping right now, ping to 8.8.8.8, so that ping works. Now, now the issue is our LAN side devices still don't know how to get to internet because the LAN IPs are not advertised on the internet. So we have to create a NATing statement on the R1 so that the LAN side can actually get to internet. Okay, so the LAN PCs can be able to connect to 8.8.8.8. So for that, we're going to, first thing we want to do on R1 is create an access list. Configure terminal, access list, sequence 10, permit 172.16, sorry, 16.20.0, wildcard mask 0. Okay, access list created. Now we can apply that access list since we already defined the internet facing IP of the internet facing side of R1 as outside. So we can now apply it. Say IP at inside source interface source list. So this one. So this 10 with the sequence we created on access list. An interface is going to go out through interface serial 1/1 overload. Okay, so that's done, and now we can do a test. We can do a test to see exactly if the LAN side can actually have internet going through R1. Okay. So let's do a quick test. I'm going to save this out. Let's go to one PC, like PC1. In order to do a test, first we have to tell PC1 who is the gateway. Okay, so if I come here and I say gateway, I say this IP address of my PC1 is 172.16.20.10/24, and its gateway is, okay, this is our gateway that we just took here. So if we say enter, okay, so it accepted, which means it accepted this IP as the IP of our PC, and this is the gateway. So now let's do a ping. Let's do a ping to let's ping 8.8.8. Sorry, let's ping 8.8.8.8. Okay, ping is going now. Ping is going, but we don't know if it's actually going through R1, R2, or R3. Let's do a trace route to see. Okay, so trace route says it's going through R1 because we know it's R1 because this is the gateway that that was defined going out serial interface 1.1 of R1. Okay, that's how we know it, and also we know it because of next hop from the PC is the 20.1, which is the LAN interface of the R1. So in the same way, I actually went ahead, since this configuration R1 is actually very identical to R2 and R3. So I actually did configure R2 and R3 already. We can just double check. Do show run on R2. So you see the fast Ethernet 00 of R2 already has an IP address, okay, 20.2, okay, the same 20.2 that's here. And then serial 112 of R2 already has an IP address 12.12.12.2, okay, it's an IP NAT outside. The other one was IP NAT inside, The facilitator 0 is always is going to be our IP net. It's going to be the inside interface. And also I configured the static route. Also configured the static route on R2, and I added the applied the access list. Okay, I applied the access list. I created the access list and I applied the access list on serial 1, 2. Okay, so let's test it. Let's test if traffic through R2 is working. We're going to do the same thing for R3. So for that to happen, we have to change the gateway IP of PC1. Okay, so instead of 20.1 as a gateway, we're going to change the gateway to 20.2. Okay, so let's see how this works now. Traffic should go now through R2. Okay, for that one, let's do first a ping 8.8.8.8. Okay, ping is working, but we don't know what route is taken. So let's do a trace route. Let's do a trace route and see. Okay, so trace route tells us it's going actually through R2 as we suspected, because the gateway for that we just configured is going through R2. So in the same way, I did the same configuration for R3. So if I change the configuration of our PC, if I change this gateway for our PC, and I give him a gateway of .3, okay, which means it's supposed to go through R3. If I give him a gateway of .3 here, means our traffic is no longer going to go through R3. R2 is going to go through R3. Okay, so let's try that. Okay. All right. Anyways, I know what's going on, but that's okay. What's going on is I'm giving the same IP 20.10 everywhere, so that's okay because it's just one IP I'm assigning for now. So that should be okay. Let's just do ping. Let's do ping 8.8.8.8. Okay, ping is responding, but as I told you, the trace route is going, the traffic is going through R3. Okay, and to prove that, if we do a trace route from this PC, we see it's actually going through R3. Okay, this is the IP, that's the gateway for the directly connected interface from R3 to the ISP. Okay, so now we know everything is working, but all what you're doing right now up to this moment is manual, and our goal is to set this thing so that if R1 is not available, R2 is going to peak over, or R3 is going to peak over. So for that, that's the goal of our video today, is to configure HSRP. So right now I'm going to start the configuration, and I'm going to go to R1. Okay, I'm going to go to R1. Let's say configure terminal. I'm just going to configure this on the fast Ethernet. Okay, fast Ethernet 00. So if fast Ethernet 00 goes down on R1, so what happens? Either this guy is going to pick over, or this guy is going to pick over. Okay, so let's configure for R1, and then let's do the same for the other routers. So interface fast Ethernet 0. This is standby group 1. What comes standby group 1? Let's say preempt. Okay, preempt. Let's go out of there. If I do show standby here, okay, nothing is happening yet. I'm going to go to R2 and do the same thing. Configure terminal interface fast 0.0. Oh, I know what's going on. Okay, I know what's going on. I will go back to R1. I didn't give the virtual IP address. I was supposed to give the virtual IP address. So say configure terminal, standby standby group 1 IP. Okay, so now I have to give the IP address. Let's see, standby group 1. Oh, what am I doing? Interface fastener 0/0 standby group 1 IP. So now I have to give the virtual IP address of the, that's going to be the same virtual IP address for R1, R2, and R3. So we start with R1. So the virtual IP address is 172.16.20.100. Let's see. Okay, all right, so go out of there, and then we say standby 1 preempt. Okay, so let's go out of there, save it. Okay, now if I do show standby, okay, so what we're seeing right now is we're seeing it automatically generated a priority of 100 for this particular router. Okay, for this standby for this particular router, and at the moment it's showing that this router is the standby, is not the active one. So maybe after a short while it's going to be active. Okay, so now it's active. Okay, it changed from state of standby to state of active because it's the one that is alone right now. So the other ones are already configured. I'm going to go to R2 and do the same thing. So R2 standby group 1 IP 172.16.20.100. I'm a slow typer, so okay, standby 1 preempt. So it's done for R2. Let's go to R3. And by the way, before I go to R3, let's do something. Let's do, if I do show standby brief. Okay, so right now it's telling me that the standby router is local. Okay, standby router is local. Okay, that's this is local, which means R2 is a standby router, and the active router is 20.1. okay, that's R1. Okay, so basically now R1 is active, this one is standby. So the state of this one, let's find out what state this router is going to have. R3. So let's go in there, R3, configure terminal, interface fastener 0/0 standby group 1 IP 172.16.20.100. they're all going to have the same virtual IP address. Okay, we see standby 1 preempt. Okay, so that's done. Let's save the configuration, and now let's find out what's the HSRP state of R3. Okay, so it says show standby brief. Okay, so what state is it giving us? Okay, it's telling us that the active is 20.1, which is R1, and the standby has moved from R2 to R3. So the standby IP originally was R2, now it's R3. The reason is because the IP address of R3 is bigger than the IP address of the IP address of R3 is bigger than the IP address of 2. Okay, so it's basically dot 3 here, and here is dot 2. So now what's the state of R1 of R2? Okay, let's find out what's the state of R2. Let's go in here, show standby brief. Now it's telling us that the R2 is, the current state of R2 is listening. Okay, so basically this is the active, this is a standby. If this guy isn't available, this guy picks over. And this, if this R1 and R3 not available, that's when this guy picks over. Okay, but this is what we're going to do right now. We're going to give priority. We're going to select which router we want to be active. Okay, and we're going to give priority to them. Okay, so let's go into configuration mode. Configure terminal into let's go to R1 first. We're basically going to select R1 as our primary route. Okay. So our primary route. Okay, interface facilitated 0/0. Standby 1. So we're going to give a priority. Okay, let's give priority for of 120. Okay, let's see, priority of 120. So we're giving a priority of 120 to R1. Okay, and let's give a priority of 110 to R2. So basically we're going to force R2 to be the standby, and then R3 is going to be have the lesser priority. So let's go out of there, save, go into R2, interface fasten 0/0, standby 1, priority for R2, let's give it 110. Let's go out of there, save, go to R3. We're going to give R3 105. Interface fasten 0/0. Standby group 1, priority 105. Okay, so now after doing this, let's check what are the status of who is the active, who is let's do that on R2. Okay, let's find out who is active, who is standby, and who is listening. If you say show standby, okay, so the priority for R2 is 110, so that's what we configured. Okay, and the so its state is standby, and we could actually do show standby brief. But we see exactly, we know the active router is 20.1, that's what we wanted. The standby is local, that's what we configured. And now the listening router is R3. So what we're going to do right now is so this is if we said if R1 is not available, in reality we're talking about the LAN side. Okay, the F fastener 00, okay, fails on R1. If that fails, then R2 picks over or R3 picks over. What if this is we have issues on the one side? Okay, so in order to track the one side, we have to track the one side, so that if one side has issues, we can also change the priority. Okay, the priority changes as well. So we're going to have to track the one side as well. So we already can track the LAN side, fastener 0, but now we have to track the one side of R1. Okay, because it's R1 is our main router. So let's get into R1. I do have, let me just check here. Okay. All right, so let's go into R1. Basically, we're going to track one interface of R1 and R2, because as we said, R1 is going to be active, R2 is going to be standby, and R3 is going to be listening. So we're going to track these two interfaces, so that if, you know, anyways, let's go into the configuration mode. Terminal, interface fasten 0/0, standby 1, group 1, standby group 1. So now we're going to track. We're going to track on R1. We're going to track interface track serial 1/1. Okay, tracking serial 1/1, and we're going to decrement the priority. Okay, if serial 1/1 is unavailable, we're going to decrement the priority by 20. Okay, so the reason we want to decrement by 20 is because we set the priority for R1 to be 120, and by default is, if we don't configure a priority, it's going to be 100. So if we decrement by 20, it means that it's going to be lower than a priority for R2, which was 110, and lower than priority for R3, which is 105. So in that way, R2 is going to be the active, and R3 is going to be the standby. Okay, so that's how we're going to track it, and we're going to test it, of course. So this is done. Let's do the same thing for R2. I'm going to save. I like to save because sometimes you actually forget what you're doing. So go to configure R2, interface fast internet 0/0, standby 1, track. We're going to track, this time we're going to track interface serial 1/2, serial 1/2, and we're going to track with a decrement value of 20 as well. Okay, the reason I'm going to explain why is we're going to track with a decrement of 20. So the priority on for serial for R2 is 110. So if we decrement by 20, it means that it's the value, the priority moves from 110 to 90. If it's from 110 to 90, what that means is that automatically it's lower than the priority for R3, which is now going to be the standby. Okay, it's going to be the standby, assuming that R1 is up. Okay, so if R1 is up, R3 is going to be on standby. But if R1 and R2 are down, then R3 should as well pick up. Okay, because its priority is is higher than all the other priorities. Okay, so it's 105. So let's test it right now. Okay, so we're going to go out of here, and remember we are not tracking interface for R3. It's pointless to track this interface because we have, if R1 is not available, R2, R3 are working. If R2 is not available, so there's no point to track R3 except we had another fourth router. So that's the logic behind it. So right now let's test. We're going to shut down the interface on R3 and let's see how that works. Okay, before doing that, let's just do show standby brief. Okay, so nothing has changed, just the configuration, nothing has changed. So now I'm going to shut down the interface, the one interface on R1. Okay, go to configure terminal, interface 0/1/1. So what I'm going to do, I'm going to do a shot. Okay, I'm going to do a shot, and before doing a shot, I'm going to come to PC1. I'm going to come to PC1, and I'm going to do some changes here on PC1. Instead of giving the IP address on PC1 is going to be 100. Okay, the gateway PC1 or PC2 is going to be 100, because 100 is the IP address that's virtual that we just configured, and with that IP, PC1 or PC2 should reach internet regardless of who is down. Okay, because the physical interfaces don't matter at the moment. Okay, so let's configure that. Let's see how that works. Before doing anything, let me just do a ping, just to be sure. Ping 8.8.8.8. Okay, responding. Let's see what is the route that is taken by PC1. It should be R1. Okay, R1 we said is the active. Okay, we just found R. So if we do a trace route, we see the traffic is going through R1. Okay, let's do a trace route. Okay, going through R1 as we configured. Now I'm going to do a continuous ping. I'm going to do a continuous ping and then shut down the one interface of R1. Okay, so doing a continuous ping right now. I'm going to shut down the one interface of R1, and what we expect to have is going to have some period of time when the ping is not responding, and then it has to switch over to the next to the active router. So I'm going to do a shot. I'm going to do a shot, come back to PC1. All right, so it stopped working. It stopped. We had a timeout here, and then they picked up. Okay, let's find out how traffic is going right now. If you go here and do a trace route, you see trace route going through R2. Okay, so our HSRP is working perfectly. Now let's do another one. Let's go a little bit more aggressive. We're going to shut down interface for by the way, before doing any shutdown, let's check who is the shows standby brief. Okay, so what it's saying is saying that R1 is in listening state. The reason it's in the listening state is because its priority change to 100, okay, from 120 to 100, because we have the decrement of 20. So the active router now is router 2, and the standby router is router 3, okay, which is exactly how we configured. So if we have to be a little bit more aggressive and we shut down the interface on R2 while the interface on R1 is still down, okay, so we're going to be a little bit more aggressive. We'll configure terminal interface serial 1/2, okay, that's the one interface on R2. Okay, so let's double check that our ping is continuous. Make sure the ping is continuous. Okay, ping is continuous here. I'm going to go to R2. I'm going to say shut. Okay, shut. Go back to R1. Okay, so there's a change here. You can see here. So I'm going to stop here just to find out how the traffic is going out, because technically traffic should be going out through R3, because this interface is shut. This interface is shut, so only this guy is available right now. So if we do a trace route, okay, that's exactly what we expected. It's going through our R3. So I'm going to bring back all the interfaces on R1 and R2, the one interface on R1 and R2. You can say no shot, no shot. Do the same, and then save the configuration. Interface 01/1, no shot. Save the configuration. Then we're going to check who is active, who is standby at the moment. Okay, show standby brief. Okay, so R1 is active again once more. Okay, and the standby is this one. I think it's just in transition mode. So the standby should be R2, but except I forgot to bring it up. Let's see, it should be R2. Okay, so we're good now. So basically we brought back all the interfaces. The active router is R1, standby is R2, and the listening is R3. So everything is set up and working exactly how we wanted. And that's all for this video. If you like this video and want to have videos like this, please consider subscribing to my channel. Click the like button. And thanks very much for listening, and talk to you next time.